This video is an introduction to the metric system. We will discuss the metric prefixes, the base metric units, and some derived units. The prefixes that we will use most often in this course are kilo, centi, and milli. Kilo, lowercase k, is 10 to the third or 1,000. 1 kilo anything is 1,000 of those things, so 1 kilometer is 1,000 meters. Centi, lowercase c, 10 to the minus 2 or 1/100th. 1 anything is 100 centis of those things, so 1 meter is 100 centimeters. Milli, lowercase m, 10 to the minus third or 1/1000. 1 anything is 1,000 millis of that thing, so 1 meter is 1,000 millimeters. Putting this and this together, since 1 meter is 100 centimeters, 1 meter is 1,000 millimeters, this tells us that 1 centimeter is 10 millimeters. The metric system has 7 dimensions or properties. All metric units must be in the base or standard unit. In this course, we will only use, for the most part, 3 of the 7, length, mass, and time. Any unit using length, which is many of them, must be in meter. If you have centimeters, they must be converted to meters. Mass is a kilogram, or kg, and time. Time is in seconds, so if you have hours, you must convert those to seconds. Thinking metric, a doorknob is about a meter above the floor. The ceiling might be perhaps 3 meters tall. 1 meter is 3.281 feet to 4 significant figures. This would mean that a very tall person, someone say about 6.5 feet tall, would be 2 meters tall. Most people are probably about 1 3/4 meters tall. 1 kilometer is 3,281 feet. Since a meter is 3.281 feet, or just over 3 feet, and a yard is exactly 3 feet, we can think of a meter as being a big yard. 1 mile is 1609 meters, or 1.609 kilometers, or about 1 2/3 kilometers. The diameter of a nickel is about 2 centimeters. The radius, which is 1/2 the diameter of a nickel, is about 1 centimeter. 1 centimeter is also roughly the width of a paperclip. 1 meter is exactly 100 centimeters by the definition of centi, and 1 inch is exactly 2.54 centimeters. 1 centimeter is also roughly the width of a staple, the width of a pencil, and the width of a paperclip. The diameter of the paperclip is about 1/10 of a centimeter, or 1 millimeter. The base metric unit for mass is the kilogram. This means that any metric unit involving mass must be in kilograms. Thinking metric. 1 kilogram is 2.20 pounds at sea level. Since trailing decimal zeros are significant figures, and accuracy is the number of significant figures, what this means is 1 kilogram is 2.20 pounds rounded to the nearest 1/100th of a pound. Mass in kilograms and force in pounds are not the same physical quantity. Mass is the amount of substance, whereas force is a push or pull that tends to change velocity. F is ma. We'll describe this in more detail later. An object with a mass of 1 kilogram at sea level would still have a mass of 1 kilogram in outer space, and it would still have a mass of 1 kilogram on the moon, and for that matter, anywhere in the universe. However, 1 kilogram would have a weight of 2.20 pounds at sea level, but in outer space, it would have no weight at all, and on the moon, it would have a weight that is 1/6 of 2.20 pounds. 1 kilogram is 1,000 grams. Penny is 2.5 grams. A paperclip is about 1 gram. A nickel is 5 grams. In the math, this tells us that 1 kilogram is 200 nickels. Here is what we have. Definition. Mass, a measure of the amount of matter in an object. Does it change with location? No. The unit, kilogram, measured with, we'll use a mass balance. Weight is a measure of the gravitational force on an object. Does it change with location? Yes, it does. What is the unit in the metric system? It is the Newton. Newton is defined using Newton's second law. F is ma, or force is mass times acceleration. So 1 Newton is a mass of 1 kilogram times an acceleration of a meter per second per second. Let's discuss the relationship between mass and water. 1 liter is a cubic decimeter. Decimeter is 10 centimeters. This says that a liter is 10 centimeters cubed, or 1,000 cubic centimeters. Definition: a liter, or 1,000 cubic centimeters, of water has mass 1 kilogram. It also says 1 cubic centimeter of water has a mass of 1 gram. Also note that a liter is 1,000 cubic centimeters, and a liter is also 1,000 milliliters. This tells us that 1 cubic centimeter is the same thing as 1 milliliter. EM, or mass density, is mass divided by volume. Since 1 liter of water has a mass of a kilogram, this tells us that the mass density of water is 1 kilogram per liter. Likewise, since 1 cubic centimeter of water has a mass of a gram, the mass density of water is also 1 gram per cubic centimeter. Doing the math, we see that a liter, which is 1,000 cubic centimeters, is also 1/1000th of a cubic meter, or equivalently, 1 cubic meter is 1,000 liters. Using the fact that 1 liter is also 1/1000th of a cubic meter, we see that the mass density of water is 1 kilogram per liter, or 1 kilogram per 1/1000th of a cubic meter, which is 1,000 kilograms per cubic meter. In summary, the mass density of water is 1 gram per cubic centimeter, or 1,000 kilograms per cubic meter. We now know that the mass density of water is 1,000 kilograms per cubic meter. We now define the metric ton, or TONNE, be 1,000 kilograms. We can now merge these two concepts to tell us that 1 cubic meter of water has a mass of 1,000 kilograms, which is a metric ton, since a metric ton is 1,000 kilograms, and the mass density of water is 1,000 kilograms per 1 cubic meter. What we now have is that 1 metric ton, or TONNE, is 1,000 kilograms. We also have that 1 kilogram is 1,000 grams, and we have that 1 gram is 1,000 milligrams. Combining the fact that a metric ton is 1,000 kilograms by definition, and that a kilogram is 2.20 pounds at sea level, we can convert a metric ton from 1,000 kilograms to 2,200 pounds. In conclusion, we see that since an English ton is 2,000 pounds, a metric ton is 2,200 pounds at sea level, they are not the same thing. We have talked about the metric base quantities and their base units: length the meter, mass the kilogram, time the second. Derived quantities are all made up of the 7 base quantities in the metric system. Volume, or the cubic meter. Density, symbol is sometimes rho, Greek letter. We use D sub m for mass density. Kilograms times meters to the -3, or kilograms per cubic meter. Velocity, or speed, meters per second. This is the Newton, or as we have mentioned, Newton is a kilogram times a meter per second per second. The A in F is MA is acceleration in meters per second per second. Acceleration is the change in velocity over the time. Change in anything is the final of that thing, here the final velocity, v sub f, minus the initial of that thing, here the initial velocity. Change in velocity is in meters per second, divided by the time, which must be seconds. Meters per second divided by seconds gives us meters per second squared, or in words, meters per second change in velocity each second. Lastly, let's compare some English units with SI, which is metric system units. SI means System International. Kilometer, 1 mile is 1.609 kilometers, or roughly 1 mile is 1 2/3 kilometers, or 1 kilometer is 0.6215 miles, or just over 0.6 of a mile. 1 foot is 0.305 meters, or 1 meter is 3.281 feet. A meter is a big yard, since 1 yard is exactly 3 feet. Or 1 kilometer is 3281 feet. 1 inch is exactly 2.54 centimeters. Kilogram is 2.20 pounds at sea level, which means that a pound is a little bit less than a half of a kilogram. And of course, a kilogram is 1,000 grams. 1 pound is 454 grams to 3 significant. 1 pound is exactly 16 ounces, and it is also 453.59 grams. By 16, we get that 1 ounce is 28.35 grams to 4 significant figures. 1 gallon is exactly 4 quarts. A liter is a big quart. Liter is 1.056 quarts to 4 significant figures. Therefore, 1 gallon is 4 quarts, or 3.785 liters to 4 significant figures. 1 gallon is also 0.785 liters, which becomes 3785 milliliters. A gallon is 8 pints, and 1 pint is 16 fluid ounces. 8 times 16 is 128 fluid ounces per gallon. Dividing, we get that 1 fluid ounce is 29.6 milliliters to 3 significant figures. In summary, discuss the metric prefixes. Metric prefixes are all powers of 10, just like our base 10 number system. We will primarily use kilo, which is thousands. 1 kilo anything is 1,000 of those things. 1 kilogram is 1,000 grams. We also use centai. Centai is 1/100th. 1 anything is 100 centais of those things. 1 meter is 100 centimeters. And we also use milli. Milli is thousandths. 1 anything is 1,000 millis of that thing. 1 gram is 1,000 milligrams. We also discussed metric base units and derived units. There are 7 basic physical dimensions or quantities in the metric system. We will primarily use just 3 of them: length, mass, and time. The base metric unit for length is the meter. Any metric unit that involves length must be in meters. The base metric unit for mass is kilograms. The base metric unit for time is the second. All derived units are combinations of the 7 basic metric units. Lastly, we compared some common metric and British units. This concludes this video on Introduction to the Metric System.